Welcome to the debate. Today, we're tackling one of the most fundamental mathematical choices embedded in our global infrastructure, the enduring split in electrical standards, specifically the 120 volt versus the 220 to 240 volt standard.
A foundational disagreement that, it continues to dictate massive engineering decisions, appliance design, and, of course, power delivery efficiency all over the world.
Exactly. And the core question we're exploring is really one of prioritized mathematics. Was the U.S. decision to stick with the 120 volt to ground standard, which is enabled by that elegant split-phase system, a mathematically justified compromise? One that's successfully prioritized ground fault safety and managed infrastructure cost over the raw efficiency you get with higher global voltages. My position is that the split-phase design successfully engineered a system that minimizes risk while still providing very efficient 240-volt delivery where you need it.
And I'll argue that the calculus of safety and initial costs only really makes sense historically. The fundamental persistent efficiency losses that are just inherent in maintaining a widespread 120-volt service represent a critical long-term technical and economic deficit. It's basically a hidden tax the U.S. continues to pay for historical inertia.
Okay, so I think we have to ground this discussion in the engineering reality of the modern U.S. home. The U.S. electrical delivery is, in practice, a 240-volt system at the service entrance. We're not running our homes off single 120-volt wires. We leverage the split-phase mechanism, where you have two hot lines, L1 and L2, that provide 240 volts phase-to-phase for all the heavy loads, stoves, water heaters, central AC, EV chargers. This gives you a massive 48 kilowatt capacity on a typical 200 amp service. But the critical safety mouth there, the compromise at the core of my position, is the grounded center tap. This is an engineering inheritance from Edison's original three-wire system. By grounding that center connection, the system ensures that the potential between any accessible hot wire, L1 or L2, and earth ground is only 120 volts.
This gives us a marginal but mathematically crucial safety buffer. If we look at Ohm's law, V equals I²R, where R is, say, human body resistance, having the driving voltage from 240 to 120 necessarily halves the resulting current, the I, that flows through a person during a shock. And let's not forget the incredible initial economic lever here. Edison's three-wire solution wasn't just about safety, it was the mechanism that achieved a staggering 60% reduction in the copper required for mass electrification in the first place. That initial cost saving wasn't just viable, it was arguably the commercial imperative that locked the whole system in.
Well, I see why you rely so heavily on that historical cost argument, but that framing treats path dependence as if it were a deliberate, optimized technical choice. I come at it from a different angle. The global consensus standard, 220 to 240 volts, is rooted in a far more elegant application of electrical physics. Europe's pivot to 220 volts a century ago, which was enabled by the more durable tungsten filament, delivered immediate, systemic efficiency gains that the U.S. was simply too entrenched to capitalize on. The underlying efficiency calculation is simple and profound. Power is voltage times current, P equals VI. So if you double the voltage, you have the current you need to deliver the same amount of power. But you have to look at the exponential nature of the loss here. This is where the physics of resistive loss becomes undeniable. Since heat loss in transmission is proportional to the current square, I²R, halving the current doesn't just halve the losses, it reduces resistive loss by a factor of 4, 75%. That is an exponential saving in thermodynamics. That 75% reduction allowed European utilities to use thinner, cheaper copper wires and extend transmission distances without the same voltage drop penalties. So while the US uses 240 for dedicated heavy loads, the vast network of standard 120-volt residential branch circuits still operates at twice the current and 4 times the resistive loss of a full 240-volt system. This represents a massive cumulative inefficiency across the entire footprint.
That I²R loss is undeniable as a theoretical relationship. I get that. But we have to look at where the majority of high current is actually drawn in a modern home. You mentioned the vast network, but the largest residential loads, the primary source at high current and thus the major I²R waste, are served by 240 volts via double pole breakers. We effectively mitigate the most significant waste right at the source where it matters most, like in an oven's heating elements or an AC compressor.
I appreciate that point that we address the heavy loads, but that really only addresses half the problem. We are still talking about the cumulative continuous efficiency costs across the existing pervasive infrastructure, the billions of feet of copper wiring in millions of homes feeding every single standard wall socket. This network runs lights, electronics, small appliances. And while you might argue that, the transition to LEDs has shrunk the energy envelope on those 120-volt circuits, that only addresses new loads. The physical infrastructure itself remains optimized for loss. That continuous 75% comparative efficiency penalty, it's an ongoing long-term tax embedded in the widespread 120-volt base. And the I²R loss isn't the only manifestation of this forced 120-volt constraint. To see a perfect mathematical proof of compromise, we just need to look at the 208-volt anomaly. It's often rounded from about 207.84 volts, which you find in commercial or apartment buildings served by three-phase Y or star power. This shows how our reliance on the 120-volt phase-to-neutral constraint creates systemic operational compromises.
Okay, hold on. Can you slow down for a moment and explain the mathematical derivation of that 208-volt value? I want to make sure the causal link is absolutely clear for our discussion.
Certainly. In these three-phase systems, you have to maintain the 120-volt link from any phase to the neutral center point. That's so you can still run standard 120-volt wall outlets in a commercial setting. But because the three phases are electrically separated by 120 degrees, the voltage measured between any two hot phases is mathematically limited. That phase-to-phase voltage is always 120 volts multiplied by the square root of 3. That calculation inherently gives you 208 volts. And the impact of that compromise is substantial. An appliance that's rated for the true 240-volt standard, which is common for commercial ovens or HVAC units, will deliver only approximately 75% of its rated power when it's connected to that 208 feed. You can see this in slow-running resistive heaters.
This mathematical necessity of maintaining 120 to neutral forces an operational compromise on higher power equipment.
You are highlighting an engineering reality of three-phase power, not a systemic failure of the residential split-phase standard. The three-phase system is designed for rotational motor power in industrial settings. The 208-volt measurement it's the unavoidable consequence of the geometry of the Y-connected system when you demand a 120-volt link to neutral. It's a purposeful engineering trade-off. It prioritizes providing a balanced three-phase supply while also maintaining that crucial 120-volt safety link. You're not forced into compromise, you're making a choice to use the most versatile configuration.
But that choice confirms the system's limitation. To accommodate the legacy 120-volt need, we are forcing commercial and large residential spaces to accept mathematically inferior power delivery, 240-volt appliances running at 75% power. That is a measurable cost in performance and time, and it stems directly from the foundational decision to lock the neutral to a 120-volt potential.
I stand by the fact that the 208-volt anomaly is an edge case of industrial reality. Let's return to the central mathematical claim of safety, because this is where the system's choice is clearly validated in extreme circumstances. We can actually look internationally to see how even 240-volt nations validate this safety principle when the risk is highest. Take the UK. They run 240 volts in their homes, but on every major construction site where brown contact and power tool faults are common, they mandate 110-volt split-phase power, center-tapped and grounded. This means the potential from any hotline to ground is a mere 55 volts. Now, why would a 240-volt country intentionally introduce this low-voltage setup for its highest-risk environments? If the efficiency argument were truly paramount, they'd just run 240 everywhere, but they don't. And this validates the core principle. Lower voltage to ground, adhering to Ohm's law, mathematically reduces the potential current during a shock. It maximizes safety, where human contact is most likely.
I acknowledge the mathematical reality. Lower voltage means lower current, and the UK example, it clearly validates the V = IR safety logic in extreme cases. However, that marginal voltage advantage is fundamentally compromised by historical and regulatory factors that create a much different real-world safety envelope. You have to factor in the US's suboptimal plug design, or NEMA plugs, which can expose live pins for a moment during connection or disconnection. And crucially, you also have to cite the less universal adoption of fast-acting leakage current protection devices, like GFCIs, here, compared to the far more universally mandated residual current devices, or RCDs, in many 240-volt countries. Look, a safer system isn't just about the peak voltage potential. It's about the total protective infrastructure around it. Our systematic regulatory inertia on universal, rapid fault protection means we rely on the passive safety of lower voltage, while higher voltage countries rely on aggressive, active protection that detects leakage current in milliseconds. And that active protection often offsets the theoretical voltage advantage we claim.
To conclude, the U.S. system is a successful engineering compromise. It's rooted in Edison's early economic necessities. It utilizes 240 volts where it matters most, for high power demands, minimizing I²R loss on heavy loads, while still maintaining 120 volts potential to ground. This 120-volt potential is a mathematically measurable foundational safety feature that serves as the first line of defense, making the overall system robust and viable.
My position. The U.S. system is a classic example of path dependence. The immense cost of changing standards has locked the country into a technically inferior setup. The systemic I²R losses across millions of standard 120-volt circuits, along with operational compromises shown by the 208-volt mathematical anomaly, demonstrate the long-term price tag of prioritizing legacy over optimal electrical engineering. Efficiency was sacrificed at the altar of early rapid mass deployment.
It's clear that both systems are functioning globally, but they arrived at their standards through very different metrics. The U.S. prioritized safety and massive initial copper savings, while Europe prioritized pure thermodynamic efficiency for the long run.
And we haven't even touched on the complexity of the frequency split, 50 Hz versus 60 Hz, and how that affects motor efficiency and transformer size, let alone the full mathematical implications of the three-phase rotational power. There is clearly much more to explore in the historical and mathematical complexities of this global grid divide.
Thanks for watching. To wind down from this bumpy ride, feel free to let the video roll and enjoy a talk on privacy and ingenious digital assets. If you research electricity and math seriously, these things can be a great supplement.
Let's talk about a simple way to take back your privacy and secure your connection online. Okay, let's get right into it. Right now, your internet provider sees every single thing you do. And the difference is, honestly, night and day. Without a VPN, you're totally exposed. With one, you're invisible. So, what exactly is a VPN? Just think of it like a secure, private tunnel for your data.
And here's how it works. You connect, it encrypts, and then it reroutes your traffic. Simple.
This gives you some new superpowers. First up, way better security, especially on that sketchy public Wi-Fi. Next, you get total privacy. It stops your internet provider and websites from tracking what you do online. And finally, freedom! You can change your location to access content from anywhere and even find better deals. Alright, so which VPN should you choose? Let's look at two of the absolute best, starting with ExpressVPN. And look, the experts all agree. It's consistently called out for being super reliable and incredibly fast. They've got servers in 105 countries, top-tier encryption, and their trusted server tech means zero data is stored. Okay, our second top pick is NordVPN, and these guys are known for one thing: unbelievable speed.
And PCMag really nails it here. They praise its huge collection of servers, which is a big deal.
It's got over 8,400 servers and comes with Threat Protection Pro to block malware and ads. So here's the bottom line. Both are amazing choices. It really just depends on what you need. Look, both are at the top of their game, which is why we fully endorse them. And get this, both services give you a 30-day money-back guarantee. So it's totally risk-free. To get you started, just check the description below for links to the latest deals and offers. This is your chance to control your digital life. So, are you ready to take it back?
Okay, let's dive into this. If you've ever felt completely overwhelmed by all the crypto talk, or maybe just a little skeptical of the whole thing, you are in exactly the right place. We're going to cut through all that noise and tackle the biggest things that hold people back. And let's be real, it's easy to see why, right? The headlines are just wild sometimes. One minute you're hearing about crypto being used for shady stuff, and the next, someone's paying millions for a digital cartoon. It's enough to make the whole thing feel, well, kind of weird and untrustworthy. But here's a thought. What if the real barrier, the thing that's actually stopping us from exploring a new technology like crypto, isn't the tech at all? What if it's actually us? The way our brains are hardwired. So that's exactly what we're going to dig into. We're going to unpack 3 super common mental traps, or biases, that can really cloud our judgment and stop us from seeing a big opportunity right in front of our faces. First up is a big one, confirmation bias. If you already think crypto is a scam, your brain is going to go out of its way to prove you right. You'll click on every negative story about a market crash, and you'll probably just scroll right past the news about major companies and countries adopting it. It's like having blinders on. Then there's loss aversion. Basically, losing $20 feels about twice as bad as finding $20 feels good. Our brains just hate losing. And with something like crypto, which can be volatile, that fear gets cranked up to 11, often overshadowing the fact that assets like Bitcoin have shown some incredible growth over the long run. And finally, we've got the good old status quo bias. We're creatures of habit, right? We like what's familiar. Traditional banking, we get it. It's what we know. Crypto comes along and challenges all of that, so our default reaction is to think, whoa, that's new and different, must be risky. It just feels safer to stick with the old way. But here's the cool part. Once you're aware of these mental roadblocks, you can start to look past them. You can step back from the scary headlines and see the bigger picture. You know, the solid technology and the growing interest from some really serious financial institutions in things like Bitcoin and Ethereum. So that really leads to the million-dollar question, doesn't it? How do you even begin to dip your toes into this world in a way that feels simple and, more importantly, safe? Well, this is where a platform like Paybis comes into the picture. It was basically built to solve that exact problem, to give people a secure, straightforward, no-nonsense way to get started. And look, you don't have to just take my word for it. The proof is right there. We're talking over 500,000 downloads, and just look at those ratings on the App Store and Google Play. People are clearly finding it to be a trusted way in. So how easy is it really? What does simplified actually look like in practice? Let's just break it down. The whole process is designed to feel familiar. Seriously, it's just 3 steps. You decide how much you want to buy, you tell it where to send the crypto, and by the way, if you don't have a wallet, they give you a free one, and then you pay. It's pretty much as easy as buying anything else online. And you know all that tedious paperwork you usually associate with anything financial? Yeah, forget that. Getting verified on Paybis can take less than 2 minutes. It's all about getting you set up quickly and securely without any of the usual headaches. This isn't some kind of exclusive club either. It's a truly global platform. Paybis is available in over 180 countries, which makes it one of the most accessible ways to get into crypto, pretty much wherever you are in the world. And hey, remember that loss aversion bias we talked about, that fear of putting a lot of money on the line? Well, this number right here is the answer to that. You can start with as little as $5. It totally removes that pressure to make a big, scary investment and just lets you learn as you go. And it's all wrapped up in a package with everything you'd need. Transactions are instant. Got a question at 3 a.m.? There's 24/7 support. You get a free wallet, but can also send to any other wallet you want. You can pay with your card, Apple Pay, all the stuff you already use. And of course, the whole thing is locked down with top-of-the-line security. At the end of the day, that's what it all comes down to. Their entire mission is built around the beginner. It's about tearing down those walls of complexity and fear and just making the whole process simple, safe, and totally transparent. So, after all this talk about confirmation bias and loss aversion, you realize the biggest bias of all might just be inaction. You know, the choice to do nothing because it feels easier. So the real question isn't just about crypto. It's about what you might discover when you decide to take that first simple step.
Thanks for watching to the end of this video. If you want more content like this, there is a playlist that should be popping up right now. Stay tuned for more. I've also made this free video for you with solutions for creativity, financial strength, and online security. I hope you'll enjoy this offer as well as all the others featured on my channel. And that concludes this video. Thanks for watching, and until next time, this is Hermolau Tube. My name is Konstantin, reminding you that your interest is the current that powers this channel.